This video is about unbalanced and balanced forces, where we know the motion of the object and we want to work the other way from motion to knowing if the forces add up to zero or if the forces don't add up to zero. So here, again, we're dealing with Newton's second law, where the net force equals ma, or the sum of the forces equals ma. And if we have the sum of the forces equaling zero, we have unbalanced forces. I just did the wrong thing. We have, if it's not equal to zero, that was a nice save there. If the force does not add up to zero, we have unbalanced forces. The object is accelerating. If the forces add up to zero, they all balance out. There is no acceleration. So let's see how we could use this to figure out something about the forces if we know the object's motion. Let's start with an ice skater, and they're gliding across the ice, just holding still and gliding across the ice at a constant velocity. All right, so what would we know about the forces in this situation? The way to think about it here is to ask, is there acceleration in the x direction? Is there acceleration in the y direction? So let's think about that. Acceleration in the x direction, acceleration in the y direction. Do we have any acceleration left, right? Well, we're told it's constant velocity. That means cruise control is on. There's no acceleration in the x direction. If we're just moving like this, there's no motion up, down. So no motion up, down means that there is no acceleration in the y direction either. So that would tell us that the net force in the x direction has to add up to zero, and the net force in the y direction has to add up to zero. If we then go to a force diagram for that ice skater, what forces act on the ice skater? Well, the earth pulls us down. That's our weight, the force of gravity. The ice is supporting them. That is our normal force. Is there anything, if they're just moving at a constant velocity, is anything pushing them forward? Is there an outside object pushing them forward? Nope. Nope, there's nothing. So there's nothing pushing them forward. Is there any friction? Well, if there's nothing pushing them forward, I don't think we can have anything pushing back because of these two. So the net force in the x direction has to add up to zero. Either we could have, 30 this way and 30 this way, or we could have no forces. There are no x forces. So the net forces in the x add up to zero because there aren't any. In the y direction, we know there is no acceleration, which means the net forces need to add to zero. And so we would know that the normal force equals the weight in this case. So that is one example of how you can use an object's motion to tell you something about the forces on the object. For another example, let's think about, I'm going to go to a hard example. Let's do a difficult example. I'm going to say that we have a plane. Oh, how do you draw a plane? And it is, there's a wing, there's another wing. And it is accelerating upward after takeoff. So it's just left the ground and it is accelerating upward after takeoff. Okay, so what could we do in this case to figure out something about the forces? Again, ask yourself, is there acceleration in the x direction? Is there acceleration in the y direction? So I said it's accelerating upward at an angle. With my standard coordinate system of y being up, down, and x being left, right, this isn't in the x direction, it isn't in the y direction, it's in both of them. There is a component of the acceleration, like that. There is a component of the acceleration, like that. So these are not equal to zero. I'm like, how do I want to write this? The accelerations are not equal to zero in either direction, which means we have unbalanced forces. All right, so unbalanced forces in both the x and the y direction. So what would that tell us about the forces acting on the plane? Okay, what forces act on the plane? We can always start with the Earth pulling down. The weight, force of gravity. And, well, okay, if you know anything about planes, we actually have several different forces. The one that the wings are exerting, the wings are holding the plane up, lifting the plane up. There's actually a lift force from the air going over the wings, the shape of the wings. All right, that's keeping the plane going in this direction. We've got the thrust of jet, propeller, whatever type of plane you're thinking about. And, well, if we've got these, we're dealing with air, so I'm going to say we've got some air resistance. And, okay, could it be in that direction? Let's think about air resistance. Air resistance is a friction force. It's a friction between an object and the air. Friction forces are always parallel to the surface. Similarly, the force of air resistance actually is opposing the motion, just like a friction force does. So here, the force of air resistance would be in this direction. All right, so what do we know? We know that in the x direction, things are unbalanced, and in the y direction, things are unbalanced. Well, we've got a lot going on here. If I think about that, that's y direction, positive y direction, negative y direction. I've got a positive x direction, and then this one. This one. This is in the negative x direction and the negative y direction. So I've got both acting there. All right, we have these forces. We know they're unbalanced. That means the upward force has to be bigger than the downward force to be accelerating upward. We know the right-hand force must be bigger than the left-hand force in order, the total force, in order to accelerate that way. So if we think about let's do the up-down. We have a positive lift, we have a negative weight, and we have a negative air resistance in the y direction. Those add up to something that is not zero. All right, so we know, in fact, if I just think about what I said, that in order to accelerate upward, the lift must be bigger than weight plus the force of air resistance in the y direction. So I would know that information. Similarly, x direction, I've got a positive thrust and a negative force of air resistance in the x direction. I know they add up not to zero. They're unbalanced. And if this thing is accelerating in that direction, the thrust must be bigger than the x component of the air resistance. So I also would know this to be true. And then if we had other information, we could use that to do some calculations and all sorts of good stuff. But just knowing the motion of this thing, just knowing its motion, we already know something about the forces, which is useful. So sometimes you'll start with the motion and then go back and say, what do we know about the forces? And then sometimes you will start with the forces and then say, what can we say about its motion? This really is the key part of Newton's second law. This is Newton's second law at its most basic. And, there's the mass in here. Mass is a constant, but what we really care about with Newton's second law is this net force and how it relates to the acceleration of an object. So that's what we've got. I hope this one was useful too. Thanks.